cursor management. Oracle allocates an area of memory known as context area for the processing of SQL statements. The context area contains information necessary to complete the processing, including the number of rows processed by the statement, a pointer to the past representation of the statement. A cursor is a handle or pointer to the context area. Through the cursor, a plsql program can control the context area and what happens to it as the statement is processed. The three types of cursors are static cursors, dynamic cursor, and ref cursor. Static cursor definitions are those whose select statements are known at compile time. These are further classified into explicit and implicit cursor. An explicit cursor is one in which the cursor name is explicitly assigned to the select statement. An implicit cursor is used for all other SQL statements. Processing an explicit cursor involves 4 steps. Processing of an implicit cursor is taken care by plsql. The declaration of the cursor is done in the declarative part of the block. The dynamic cursor is made possible in plsql only through the use of dbms SQL built-in package. These cursors are dealt with the database triggers and built-in packages. A cursor variable is a reference type. A reference type is similar to a pointer. It can name different storage locations as the program runs. In order to use the reference type, the variable has to be declared and the storage has to be allocated. Ref cursors are further classified based on the return type. Strong cursor and weak cursor. A strong cursor is a cursor whose return type is specified. A weak cursor is a cursor whose return type is not specified. We will just see an example of static cursors, which is the explicit cursors. The set of rows returned by a query can contain 0 or multiple rows depending upon the query defined. These rows are called the active set. The cursor will point to the current row in the above set. After declaring a cursor, we can use the following commands to control the cursor: open, fetch, and close. Open statement executes the query, identifies the active set, and positions the cursor before the first row. The fetch statement retrieves the current row and advances the cursor to the next row to fetch the remaining row. After processing the last row in the active set, the cursor is disabled with the help of the close command. We will just see with an example about the explicit cursor. How to create the cursor procedure. As we are working on an explicit cursor, we have to declare under a declarative part. Cursor name we are defining is A. Suppose we are taking the EMP number 7369. Now a begin part starts here after declaring a cursor. After that we have to open the cursor by open keyword. Then use loop. Open a cursor means we have to search the cursor by fetch close the cursor. At last, see table updated. To check whether actually it has been updated or not, we have used the 7369 EMP number. Previously the salary was 800. After updation 2000 value are there. So we will just check it. Select star from EMP. See, 2000 has been updated. So through cursor we have seen how to update the records. First we have declared a cursor, then we have to open a cursor. Fetch statement retrieves the current row and advance the cursor to the next row to fetch the remaining rows. In section wise it will search through the feature of cursors. See here, updation. If not found that particular EMP number, exit when a% not found. That value is not initialized under a cursor, so it should exit. If it found, we have just prompt a message table updated. After opening a cursor and fetching a cursor, we have to close a cursor. So in 4 parts we have defined the cursors. Cursor declaration, then opening a cursor, fetching a cursor and closing a cursor. This is inside the explicit cursor but not in implicit cursor. It will automatically declare. No need of defining in 4 parts. So next video we will cover the details concept